Hi, welcome dear students. So today in this section, I'll be solving problems from velocity and displacement with a constant acceleration. And these problems are given on page number 51, practice D in your textbook. So now let's start with question number 2. Question number 1 we already solved. Question number 2 is an automobile with an initial speed 4.3 meter per second. So VA is given, it is 4.3, accelerates uniformly at the rate of 3.00 meter per second square. So that is its acceleration. Find the final speed and displacement after 5 seconds. So you're looking for VF, the final speed, and the displacement delta x after 5 seconds. That means delta t also given there. So I'll just write on the values given there. Question number 2. An automobile with initial speed. So your VI is going to be 4.30 meter per second, accelerates uniformly at the rate of 3 meter per second square. So your acceleration is 3.00 meter per second square. Find the final speed and displacement after 5 seconds. So delta t is given, that is equal to 5 seconds. You're looking for what? You're looking for final speed Bf. Okay. Also, you're looking for delta x. Okay. So the equation you're going to use for Vf, you know, Vi is given, A is given, delta t is given. So you're going to use the second equation. Vf is equal to Vi plus A delta t. So just plug in the values now. So your Vf is going to be, Vi is 4.30 meter per second, plus your acceleration is 3.00 meter per second square times delta t is 5 seconds, 5.00 seconds. So this is going to be 4.30 meter per second plus 3 times 5 is 15. Okay, meter per second square times second is meter per second. So 15 meter per second. So your VF is 15 plus 4.3 is 19.3 meter per second. So this is your VF. Okay. And next game, we have to find out delta x. For finding out delta x, we can look at the equations. If you look at the first equation, delta x is equal to half into VA plus VF into delta t. That equation you can use, okay, because VA is given there, VF just now we calculated, and delta t is also given there. So you can use that equation. Also, like you know, you can use the third equation. Delta x is VA delta t plus half A delta t square. So both these equations will give you the same answer. Here in this case, I'm going to use the third equation. It's up to you. You can use either the first equation or the third equation, okay? So third equation is delta x is equal to Vi delta t plus half A delta t square. Okay, so that's going to be Va is equal to 4.30 meter per second times delta t is how much? 5 seconds plus half into acceleration is how much? 3 plus delta t square times delta t square. So that's 5 square. Okay. So 4.3 times A delta t, 3 times 5 plus half A delta t square, 3 times delta t square. So the answer is 59. Okay, so even you can, if you want to check with the first equation, that also will give the same answer. See, I will just show you. If I'm going to use the first equation, delta x is equal to, okay, that also I will show just for your, like, you know, if you want to use the first equation, okay. as another way here. Delta x is equal to half into Vi plus Vf times delta t. If you try this equation, this also will give you the same answer. You can just try it. Okay, Vi is 4.3 plus Vf is 19.3 divided by 2 as okay 11.8 times delta t. Delta t is 5. See, that also giving you 59. Okay, so that's answer for number 2. And now I'll do question number 3. In number 3, you can see a car start from rest. If it start from rest, its initial velocity is 0. And travels for 5 seconds. So the time duration is given as 5 seconds with a constant acceleration of minus 1.5 meter per second square. So acceleration also given. What's the final velocity of the car? So you're looking for Vf. How far does the car travel during this interval? That means delta x. So Vf and delta x is the one you need to find out. Okay. So first you write down the values given. Question number 3. A car starts from rest. So your initial velocity Va is going to be 0. And travels for 5 seconds. So your time duration, time taken is 5 seconds with a constant acceleration of minus 1.5 meter per second square. So this is minus 1.5 meter per second square. What's the final velocity of the car? So you're looking for Vf. Also, you're looking for what? How far does the car travel during this time interval? So that is delta x. Okay. So same like before, you are going to use which equation? Vf is equal to Vi plus a delta t. So that is equal to Vi is 0 plus acceleration is minus 1.5 meter per second square times time duration delta t is 5. So this is going to be how much? You can just multiply 1.5 times 5. So that is going to be 7 minus 7.5 meter per second. So that is equal to Vf is going to be minus 7.5 meter per second. Okay. Now they are asking you how far the car traveled during this time interval. So that means we are looking for delta x. So what's the equation for delta x? Here you have Vi, you have Vf, you have delta t, everything is given there. So as I told you, you can use either equation 1 or equation 3. Okay. So if I'm going to use equation 3, this delta x is equal to Vi delta t plus half a delta t square. Since Vi is 0, this term is going to cancel. Okay, this term is going to cancel since Vi is 0. So your final equation reduces to, you can see on the right side, delta x is half a delta t square. So your delta x is going to be half times, once again I'm telling you this Va delta t is going to be 0. Why? Because Vi is 0. So the equation reduces to half a delta t square. So that is half times, what's the value of A? Minus 1.5 meter per second square times delta t square. Time is how much? 5 seconds. So this is going to be so your answer is 18.75, and you can see that all the values are given in two significant figures. So you can round this to 19 meters. Okay, so the value of delta x in this problem is 90 meters. Okay, now we will do question number 4. Question number 4 is a driver of a car traveling at 15 meter per second applies brake. So his initial velocity is 15 meter per second, causing a uniform acceleration of minus 2 meter per second square. Of course, he's going in the positive direction. He's applying brake, so he's slowing down. So that's why the acceleration is coming as negative. How long does it take for the car to accelerate to a final speed of 10 meter per second? So the car reduces speed from 15 meter per second to 10 meter per second. So what will be the time taken for this? So that's the question. And also they're asking how far has the car moved during this braking period. So when you apply brake during that time, so the speed reduced from 15 meter per second to 10 meter per second. So it will take some time for that. So during that time, the car has traveled a distance. That distance they are asking in this question. So now we will write the values given there. A driver of a car traveling at 15 meter per second. So your initial velocity VI is 15.0 meter per second. Applies brake, it is having a uniform acceleration of minus 2.0 meter per second square. So the acceleration minus 2 meter per second square. How long does it take to accelerate to a final speed 10 meter per second? So your VF is 10.0 meter per second. How long? You are looking for delta T. Also, you are looking for delta X. So for solving this, you are going to use which equation? The second equation. Vf is equal to Vi plus A delta T. So here, the value you need to find out is delta T. So what I'm going to do, I'm just going to make a rearrangement. Just bring this Vi to left hand side. So Vf minus Vi is going to be A delta T. So therefore delta T will be equal to Vf minus Vi divided by A. So that's equal to, what's the value of your Vf? 10 meter per second minus, what's the value of Vi? 15 meter per second. The whole divided by acceleration is so much? Minus 2.0 meter per second square. So 10 minus 15 is minus 5. So that is minus 5 divided by minus 2.0. So that is going to be how much? This is 5.00. Okay, I forgot to write that numbers. Okay, you can fix the significant figures there. So this is going to be 2.5 seconds. Okay, 2.5 seconds. So this is the value of delta T. And next thing, what you need to find out, how far has the car moved during this time interval? So again, you are going to use the third equation. What's that equation? Delta X is equal to Vi delta T plus half A delta T square. Or you can use delta X is equal to half into Vi plus Vf into delta T. Okay, both will give you the same answer. So that's equal to, what was the value of Vi? Vi is 15. So 15, 0 times delta T value is how much? Just now we calculate the value of delta T, 2.5 seconds. Okay. 2.5 seconds times, sorry, plus half times, what's the value of acceleration here in the question? Minus 2.0 half A delta T square. What's the value of time? Just now we calculated 2.5. Okay. So this is going to be 15 times 2.5 is 37.5 Not writing the unit, I'm just solving it, okay? Plus half times minus 2 times 2.5 square. So that's going to be minus 6.25. So that is going to be 37.5 minus 6.25. So that's going to be 31.25. And here, the answers are given in like, two significant figures. So you can round this to 31 meters. Okay. And I will show you the same problem with the first equation. First equation was which one? This one, I'm doing it in another way. The same problem with another equation. Delta x is equal to half into, you don't want to do both method, okay? It's up to you which method you want to use, okay? Vi plus Vf into delta t. And this is going to be half into, what was your Vi and Vf? Vi is 15, Vf is 10. So 15.0 plus 10.0. What was your delta t? Delta t is 2.5 seconds. So that's going to be 15 plus 10 is 25. So 25 by 2 times 2.5. You can see you're getting 31.25. See? So that is, you can fix two significant figures. See, you use two different equations, but both are giving the same answer. Okay? I hope you understood this section. Thank you.